A question on the relative strength of the nitric acid and nitrous acid. It is stated that nitric acid is a strong acid while nitrous acid is a weak acid. HNO3 is nitric acid, HNO2 is nitrous acid. Why is nitric acid a stronger acid than nitrous acid? Okay, and for this, the structure of the nitric acid and nitrous acid are separately provided to us, and we have to make out and select the correct option. Select one which is correct, which is out of these four options. Obviously, we have to review all these options and then find out the correct one. Now, as we find here, nitrogen has a larger atomic radius than oxygen. This is wrong. This cannot be an answer to the strength of the acid. Nitrate ion has greater resonance stability than nitrite ion. This appears to be correct, and we shall take up the reasons for it. We have to learn it. Nitrous acid exhibits greater steric hindrance to the loss of the proton than nitric acid. No, it's not correct. Nitrogen is more electronegative than oxygen. This is also ruled out. And therefore, we have to look into the option B here, that nitrate ion has greater resonance stability than nitrite ion. It is because that the strength of the acid is related to the ability of the acid to donate a proton to the solution. This is known to us. And nitrate ion is the conjugate base of nitric acid, whereas NO2 nitrite ion is the conjugate base of nitrous acid. Now, the conjugate base of nitric acid is more stable than conjugate base of the nitrous acid, making the proton release reaction in nitric acid more favorable. That's why nitric acid is stronger than nitrous acid. And further, if you look at the structure of nitrate ion, we find that nitrate ion has trigonal planar structure, and it is more stable than nitrite ion. It has three resonating structures. Well, these notes are provided to you for your reference. It has three resonating structures, and the resonating structures of nitrate ion is represented here. This is nitrate ion, and having three resonating structures, whereas nitrite ion has only two resonating structures. Accordingly, more the number of resonating structure, greater is the stability of the ion, and therefore the conjugate base of nitric acid is easy, and it is favorable to release a proton. And therefore, this would be the correct answer. Okay, then what we find, that greater the number of resonance structure, greater is the stability or delocalization of the electrons, and greater will be the stability of the ion. That's there. And if you come back and look at the options again, we find that here option B is correct. Nitrate ion has greater resonance stability than the nitrite ion. Well, this is the correct answer. And option A, C, and D doesn't fit so far as the stability or the strength of the acid is concerned, or the stability of the nitrate or nitrite ion is concerned. That's why the option B is correct. Okay, thank you. Please go through the question. It has been a very good question. Please do subscribe to our channel.